I'm going to explain how TCP windowing works using the largest possible TCP window size I possibly can. Act that. By the time we're done here, we will dig into how data transfer works after the TCP three-way handshake completes. I decided to go a little more modest than I did in the last video when I was trying to cram so many TCP concepts into one. So the takeaway that I wanted you to grab from the last video was I get how the TCP three-way handshake works. I get how when I have a client wanting to talk to a server and get some data transferred, how they start that session. And in this video, I just want to boil it down to one. But the key is that one is a really big deal. TCP windowing is the key to often diagnose performance issues in a network environment. Your window size will tell you, or at least give you a clue, which is the design of Wireshark. It gives you clues of where to look to solve your issues. It will give you a clue of what sort of things are happening to cause slow network connections. Now, in the last video, the focus was on the session startup. We had our computer right here asking a web host, hey, I'd like to communicate. SYN. And we zoned in especially on the sequence numbers and acknowledgement numbers, which is how TCP keeps its communication in sync, if you will. It ensures all the data gets there. Here, I'm going to send you a whole bunch of stuff, and then the acknowledgement number indicates this is exactly what I received, and now my computer knows, okay, I either need to resend that data or I can go on and send some new data. But now I want to focus in on exactly how much data can I send. You see it happen right here when we first sent the SYN packet. My computer indicated, hey, I've got a win of 64,240. If I click on this packet and scroll down here, you can see that's right in the header information. Window size value 64,240. That's my computer telling the server this is the amount of data that I can receive. Just for visualization, imagine Bob was me. That's the client. Louis is the server. I guess that would be Luis. But where's the E? My computer contacted this server and said, I would like to start communicating with you. Oh, and by the way, I can receive 64,240 bytes of information. The server replies with its SYN-ACK, acknowledging that information, acknowledging that it can send that much data, but then it also says, I can receive 4,380 bytes of data. What? That doesn't make sense to me. My computer is probably a little minuscule device compared to the massive server that's running the data. Why can my computer receive so much more data by default in this original communication than the server can? Think about that for a second. Why do you think? Think about it from a roles perspective. The server is not designed. It's not intended to receive a whole bunch of data from that client unless it was some kind of Dropbox or AWS S3 bucket, which just stores information, Google Drive, those kind of things. And in that case, the server may be geared a little bit differently to have a much larger window size because it's geared to receive. But the average web server isn't there to receive. It's there to send. As a matter of fact, it could be a vulnerability if it had an extremely large window size because somebody might pull off a denial of service attack and just send a whole bunch of data. And it's like, I can't keep up, and starts dropping data left and right? So it behooves the server that's not intending to receive a whole bunch of stuff to have a small window size, whereas the client, who is a leech, think about what we do on the internet. We surf, we consume, we watch our movies, we do all this kind of stuff. We're the ones, the clients are the ones downloading. They're the ones that need that larger window size to get a whole bunch at once. And hang on, I want to make sure before I go on, what's the benefit of having that larger window size? It's more data that you can receive before you send an acknowledgement that it was received. It helps you be more efficient. I mean, think about how I started this video, right? I started by saying, I'm going to give you as much possible information. I can't remember what I said. So a whole bunch of stuff, right? But imagine if I had to pause and you had to acknowledge between each word. I would say, you'd go, got it. I don't even remember what it said. I will. Got it, right? See how inefficient that is? And that's why having a larger window size allows you to send a whole bunch and then get one acknowledgement that I've got it. The beauty of that large window size is our networks of today are so much more reliable than they were back in the day. So it allows TCP to grow. Well, but up to a point. Check this out. It seems a little strange that our client would start with a window size of 64,240. Is that just like a value it picked out of the air? Well, remember, TCP was designed back when, we had nothing compared to the networks of today, right? We were like, oh, look, a 1200 baud modem, right? Like that's the kind of era that we were in. So a window size of 64,000 was huge, and that was hard coded. The actual window size, it's a binary value, 65,536, I believe is exactly what it comes out to. But that's the maximum. You can't get bigger than that. So the powers that be said, you know what? Let's add a multiplier. Let's add an option. Since the window size in literally the TCP protocol definition can't be larger than 65,536, why don't we add a multiplier? And if you look right here, look at this. Already, already the client is like, you know what? I think I can get a little bit more out of this. But if you look down, he shrunk his window size value. What? What's going on? Well, what he started to do was use the window size scaling factor of 256. That's a multiplier. That's saying I can send 1,026 times this value, and then they can increase their window size from there to send a whole ton of data. Notice as the server goes down, it increases its window size, but ever so slightly. At the very beginning, it's like, hey, 4,300 is about all I got. Okay, I can do 4,700. And by the time we're down here, like, okay, how's 5,200, right? 5,232. So the server is slightly increasing its window size, probably because it needs to be able to receive some of the acknowledgments for all the data that is being sent from the client. Or it just might be just slightly increasing it just in case it sees any fragmentation or any excess acknowledgments that don't need to be there. This is all automated behind the scenes. As the computers, as the devices that are sending it, and it could be anything, a computer, it could be a thermostat, or the Internet of Things, right? All kinds of things are sending across the networks. As they detect a more reliable connection and they realize they have the buffer space to keep up with that. Because remember, it's not just sending across the network. The client has to receive all that, process it, put it all back together. So if it's got a really tiny processor, it might be like, whoa, slow down. I can't process all that data, right? So as those two things occur, reliable network and a processor that can keep up with the data, it will increase the window size, and it does it pretty quick. We only see the window size hit 262,000 from the client perspective simply because this was a example of a simple HTML page, right? This was an extraordinarily simple web page, which doesn't really need a lot of data transfer. As a matter of fact, this string right here, you've pretty much sent the whole web page. So now how does this apply to you, the network engineer that's learning how to troubleshoot network environments? So you're looking at Wireshark and you're watching the window size and it starts to go up and then all of a sudden it starts to go down. Where do you look? Put the puzzle piece together. What do you start looking for? Think about it. You look in two places. One, do we have a network congestion issue that's happening that's preventing the streams from going through and the devices start decreasing their window size because they're losing data? That's one of the reasons the window size decreases is because data is lost. It detects it's like, okay, let's condense this down. It's almost like when you're trying to communicate and you're having a hard time understanding somebody either because of a thick accent or because of choppy cell phone connection. You start going, okay, did you get that? Yeah, it's kind of that real frustrating communication. That's what a computer does in the case of network bandwidth. The second thing that you look at, if you look at the network and you're like, looks fine to me, look at the server, look at the client and their processor. Are they maxing out to the point where they can't keep up with the data and they have to slow down because of a resource limitation on the device itself? Do you see why there's so much finger pointing? The server guys are like, it's a network issue, and the network guys, it's a server issue. It could be both, and Wireshark and understanding how TCP works is your way of determining where that pointer should go. We've now dug a little into how data transfer works with TCP after the initial three-way handshake completes. I hope this has been informative for you, and I'd like to thank you for viewing.